live stream for January 17th. I'm Geology Professor Shawn Willsey. We'll be joined by some of our good friends at NatureEye here in a minute when we get the drone up and going. That'll be in about maybe 5 to 10 minutes. But I thought we'd just go ahead and start and maybe talk about some of the data and an update. I was last with you on Monday when we did a flight over the cooling lava field, which at this point has completely solidified. Let me close this down here. I've got one thing open. There we go. Okay. So the plan for today is we'll get the drone up and flying around. Uh, According to NatureEye, we're able to fly over the town a bit, so we can do that as well. We'll fly over that cooling lava field. We can check on the progress they've been making with putting up more of the berm or the wall around the perimeter of the town. I've got some of the science we'll look at, the data, especially look at some of the GPS data, which I think is a little bit, it's much more messy than what we were seeing earlier, but some interesting relationships. And the Met Office update, I think, is really revealing as well, the most recent one there. So that's the plan for today. Maybe we can go ahead and start here in a second. I told some folks bottom of the hour, so we might stall a little bit here and get going, but appreciate everyone for joining me no matter where you are. It worked out really well for me individually when NatureEye contacted me because we had more snow last night, and normally I'd have classes this morning and wouldn't have been able to do this, but we had enough snow overnight that the college and the local school district called a snow day, and so we were able to schedule this live stream. Okay, so what do I want to start with here? Let's give a quick shout out to all the folks out there. I won't be able to read all the names, but in looking through a few of them a few minutes ago, it seems like if you're in the northern hemisphere, in a lot of places, it's still quite cold. And then I remember seeing one from Australia. It was very hot. So we got sort of the both ends of the spectrum in terms of weather. To update you on what's been happening the last day or two, we had, of course, the eruption on Sunday. That eruption only lasted, I think, something like 41 hours. It was a very quick eruption from start to finish. And that lava field is cooled and solidified. It did damage 3 homes on the perimeter at the north end of Grindavik. And so that is probably the biggest news that took place in the town. But of course, now we have the ongoing threat of future activity and eruptive events that will need to be addressed and dealt with. And that's where this is just it reminds me so much of what was happening in the Puna area on Hawaii in 2018, because every day just brought a new set of threats and challenges. People were displaced from their homes for weeks, if not months. And then ultimately some of those homes were lost. And it was a slowly evolving and slow motion sort of disaster that took place over the course of I think about 2 months or so there. And this is reminding me so much of that. And so it's a very difficult situation to deal with. So let's go ahead and maybe jump right into some of the data and bring you up to speed on that a little bit. Let me open one more little window here. Running these live streams, especially with the drone flight, is a bit of a 3-ring circus. So you got lots of things going on and open. Excuse me. And today, I do want to give a quick notification. We have a moderator. So Susan is our moderator for today, and appreciate her for serving in that capacity. And she'll aggregate all your questions as best she can and put those together at the end and get those to me. So you guys can send your questions to her. Susan, if you maybe could remind folks how they can, there she is, Susan Helmer. If you could remind folks how you want the questions formatted so you can put those together. But appreciate you doing that. Very helpful for me. And also thanks to NatureEye for providing this opportunity to do the drone flight. being able to operate it. This might be our last one for a little while. Some of the individuals on the ground that have been helping us with the drone need to head back home for a bit. And so I imagine, unless there's another eruption very soon, we'll probably have a little bit of a break from the drone flights while those folks kind of head back home. And then always, of course, want to thank Amanda Jo for her help in providing updates as well. She's probably not on the live chat today because she's dealing with some other more important issues in her life, but just want to always thank her for her help and support in putting up these updates together and informing people as best we can. So let's just start with some of the data we have. And I think I want to start with the Met Office update. And so this is from yesterday. I believe this is the most recent one. They might have a newer one out in the last hour or so. I haven't checked, but this is important enough that we need to probably read through it. And then they have a really instructive map that I want to spend some time looking at. So let's just read through this together. Magma accumulation continues beneath Svartsengi, so that's the power plant, at a rate similar to that of the last two eruptions. So the magma that's rising into this shallow magma body the influx is still what we saw during the last few weeks, if not month or so. This is a result of the scientific consultation meeting held this morning. As in the eruption of December 18th, magma flowed from the collection point under Svartsengi to the east and formed what they call a magma tunnel, what we're calling a dike. Okay, so a vertical or nearly vertical conduit or fin, a planar fin of magma that stretches from Stora Stogafeld, that's the hill to the east of the power plant, north and east, and then south under Grindavik. This is confirmed by computational models. They also show that the source of magma was probably slightly further west now than before, and therefore the GPS measurements differed in some ways from what was seen on December 18th. And so they've got some data to suggest that the magma storage zone was a little bit further to the west. And that's one statement that I'm a little bit confused on as well. And so I'm waiting to see if we can glean some more data related to that and find out some more information there. Continuing, when a magma vent forms near the surface, the Earth's crust is strained and land sinks over the center of the magma vent. So I love that the Met Office here is actually taking this update and this opportunity to educate people about what's going on rather than just listing the nuts and bolts of the data. So again, when a magma vent forms near the surface, there's strain on the crust and you actually get sinking right over the tip of that dike. And I might have a graphic here I can pull up later to show you that. So as a dike is propagating up towards the surface, you get the land and the crust above it actually sinking, and it might sag, but a lot of times the sinking is accommodated by faults, small little fractures that allow it to drop down in the center right above that propagating dike, and then the flanks of that stay elevated. Oh, okay. So we're going to cut out from the update real quick because Johan's ready with the drone. So we're going to shift over to that. And again, thanks to Johan and all the folks at NatureEye for providing that. So we'll jump back to that Met Office update here in a bit, folks. Looks like we're looking towards the southeast there, Johan. What direction is that? Oh, we're looking to the northeast. I can see it on the map. Okay. Okay. Okay, so we can swing around to like the west side, the north end. Okay, copy that. So Johan just informed me we can't fly above 100 meters and we are not allowed to fly over the north side of the town. So we're ready when you are, Johan. Right now we just have a gray screen. There we go. Now the camera's on. And are we good for takeoff? Video looks great, and I'm ready to go when you are. Okay. Okay. Here we go. Okay. Thank you. Okay. So here we go, friends. So we're looking out over the lava field here. So again, I'm in my office in Idaho, operating this drone here, and we'll probably stay pretty low here, but we've got a nice view here of the berm that's being constructed. So you can see some of the construction workers there and the berm that's going in. I'll just give you a little bit of a, maybe swing around a little bit here so you can see what's going on. Oh, it's a little glitch there. Oh, here we go. So there's the rest of the town, looking straight towards that second fissure. So there's that second fissure that opened up straight ahead of us that destroyed 3 homes. Just maybe a quick swing around here towards the town and the harbor. One of the Coast Guard boats out there in the distance. And then we're swinging around towards the west here, looking out towards the tip of the peninsula. So we'll head out over the berm in the lava field here and take a look at what we can see. There we go. So it's showing me a poor internet connection, Johan. I don't know if that's affecting the controls at all. Yes, yeah, it's responding now. Thank you. So this is the distal end of the lava field that started to pour around the berm, the structural wall that was erected. Remember that the lava field took out lava flow took out the highway, the main road into town. Still a little bit of connection issues, Johan. It's kind of occasionally giving me a gray screen. Yeah, it says poor internet connection with only 2 bars to 3 bars. So that's a Starlink issue. Okay, yep, no problem. Yeah, Johan's going to address that issue. We'll just pause here for a second and look at the flow field there. You can still see some areas of the flow field still actively degassing. And again, this can take several weeks to months for the lava to cool. And the thicker parts of the flow where it's, maybe upwards of 5 to 8 to maybe even 10 meters, it can sometimes take even longer. It can take sometimes years for the lava to completely cool and solidify. So even though that looks black and solid and you probably could walk on it, it's still quite hot. There's still fractures and cracks where, um, yeah, yep, looks like we're doing good. Okay, thank you, Johan. Okay, thanks. So there's the berm there. We had seen, I believe this was the spot we saw a lot of smoke coming up earlier on Monday, and there was some construction materials by the road that were on fire. I don't know if that's still what's going on there. That could be also the pipeline that runs through there. So maybe there's some water in the pipeline that's flashing to steam. Not totally sure there, but you can see some of the construction workers there. Up ahead's the greenhouse that was protected by the berm, and then you can see where a little tongue of some of that lava poured over the berm near the greenhouse. But by and large, I thought the protective wall was a great investment, and it was largely effective. Um, Remember that we did have parts of this fissure here that did erupt south of the wall or the berm, and so that was helpful, or excuse me, that was one of the problems is we had some of that lava erupting on the wrong side of the wall. We did on Monday too have one last little spatter section that was still active. That's pretty much died down. Um, and then that last little bit of smoke you see there, when we flew over that on Monday, that was some of this construction material, aggregate that's in this quarry that was still kind of burning. So I'm assuming that's what that is there. But we'll head up towards the north end and then let's head back down towards the south end and maybe come around to the west side of town a bit. So there's some fresh baby earth for you. That black rock below us is uh, 2 days old, 3 days old maybe. You can see where some of the like spatter, fine spatter from this vent just ahead of us here actually draped onto that hill to the left, and you can see some of that black just plastered against it. There's also a few spots on the flow field still incandescent and glowing. We can maybe zoom in on those a bit. So we use the zoom controls on the camera and look at those a little bit closer. And then you can see some of the gases being released from the, let me get up here a little bit, gases being released from the flow field are flammable, and those ignite when they reach the surface. So you can see some of those flames there. Pretty incredible. So we'll head up a little bit further, and then I want to spend a little bit more time at the south end of the flow. So here's one of the vents, one of the cones just right there in the middle of the screen. This was, of course, active. That cone right in front of us there was active on Monday, and now there's no longer any incandescent material there. So and Johan, I lost control for a second here. It says current controls are currently disabled. Oh, there we go. Okay, yeah. Okay, thank you. Yeah, he said there was some heavy equipment that came by, and so the connection was lost a little bit. So we'll head down towards the south now. There's the berm right across the flow field there, one of the vents just to the right. And let's head towards the edge of this flow field to the second fissure that opened up that we caught on Sunday. That was a uh, real exciting moment for me. I mean, it was heart wrenching because we knew those homes were there, but it was exciting as a geologist to watch that fissure open up and then lengthen and then start to form its own lava field in real time. That was pretty exciting. So the extent of this flow field is a little bit smaller than the December 18th flow field. I don't have the measurements offhand here, but not nearly as large. And definitely smaller, I believe, in addition, smaller than the lava flow fields we had from Fagradalsfjall, the 2021 to 2023 eruptions. We had 3 eruptions off to the east, and those were also considerably smaller. So we'll drop down a little bit here, take a look at this small flow field. Back up a bit, get a quick picture. You can see a lot of degassing here on the smaller flow field and the smaller fissure. We can see where those 3 homes were. Those now are lost. And we're not allowed to fly over the homes here, so we'll turn to the west and move around the edge of the town. And interesting here, the work on the berm continues. I think they've probably still been working 24/7 to get more of that berm or that wall lengthened. So you can see some of the heavy construction equipment here. Um, and with this last eruption, one would guess they probably have several weeks until the next event, if there is a next event, and there very likely is. We'll look at the data here for that in a bit. But lots of work going on there. So this inner berm, now that I think they've realized that that outer one was obviously too far out. The lava overtopped part of it. And so now we're working on this secondary structural barrier just below us here to protect the town. And you can see how that extends around this western side right here. That's the naval transmitter station, the big tower right in front of us there. If you get on Google Earth, you might see some big circles over there on the landscape. Looks like they got a little dusting of snow since our last live stream. And so now that we're on the west side of town, I think we are okay to be over the houses a bit and the community. And what we can look for here is some of the fractures and cracks that might be running through parts of town. Oh, it sounds like we're going to have to land the drone a little sooner than we anticipated with some of the public officials. So this might be a little bit shorter, but we'll take a quick look and swing around a bit. So our drone company is just following whatever the public officials are indicating. Straight in front of us is a big section where there was a large fracture. This is one of the big intersections in town. And you can see they patched up a bunch of it, but straight in front of us, right in the middle at that intersection, is where they have a big crack system that runs through town that looks like they filled some of that in. And that runs under parts of the rec center and swimming pool complex over in this area. And I'm going to take us back out to the west end of town just so we're in a good spot when they need us to head out and land. Okay. Okay. Yeah, Johan tells me I have a few more minutes to fly over the town, so we'll maybe swing back over here and he'll let me know when we need to abort. So some of the housing units there, then again looking at the main part of town, you can see the soccer stadium there on the far left. And some of the big, there's the supermarket. And okay, so Johan tells me I need to head back, so you can see some of the fractures there. We'll swing around and bring it back towards the landing spot. So yeah, just grateful for whatever opportunity we have to take a look at things. I think this is valuable for us to see a little bit of the town, because I'm hoping this will really drive home to many of the viewers watching that, this is a community. These are people's homes. There's a little gas station right there. I've eaten in that gas station where that car just pulled out. This is a community of almost 4,000 people. And so it's easy sometimes to, wherever you are in the world, just watch this and be somewhat, um, I don't want to say blinded, but just, it's somewhat abstract. And so hopefully, looking at these houses, thinking about the homes and the families that live there, maybe gives the situation a little more, it makes it a little more real, a little more concrete. Okay. Yeah, just one last photo there, just of the houses. And the road there off to the left, that's the road that heads out to the west towards the end of the peninsula. And that road, along with the one to the east, are now the only roadways that will get you in and out of Grindavik, with this north-south road now severed. So Johan's going to take us back now, so we'll stay with him for a little bit longer. And when we wrap up our flight here in a few minutes, we can turn back to providing an update, looking through some of the data. We'll finish up that Met Office update. So thanks again, Johan and NatureEye, for providing this opportunity. Remember, if this is something you'd like to do, you can go to natureeye.com. You can book a flight for yourself or for someone else. If you put in my name, Shawn, SHAWN, and then fly, you can also get a $10 discount on your flight. And they have other locations to use, other places in the world that you can fly drones and take photos and kind of have that interactive experience. So thanks again to them for that. And I'm going to go ahead and shut down that window there. So, okay, so hopefully that was helpful. And let's continue our update. So remember, we were looking at the Met Office update, and I think there's some important information here. That's why I'm reading it with you. Usually that's not real exciting, but I think there's some valuable, it was a valuable update when I ran through it. So we talked about the fact that right above the dike or the vent that we get subsidence, the land sinking due to the stress conditions there, and that usually forms fractures. So consider that once we get to the GPS data, because you're going to see some GPS stations that drastically moved down since Sunday and some that actually have drastically moved up. Let's see where we were. Now, 2 days after the magma tunnel formed, the meter in Svartsengi should start to show subsidence if magma accumulation had stopped. So given that we erupted some of this magma, we should start to see it dropping a little bit. Remember, I've talked to you about that inflation deflation trend, right? Inflation, eruption, deflation, inflation, eruption, deflation. But it says here this is not the case, and it's therefore clear that magma is accumulating as before. And so the magma influx into this shallower magma body continues to go on as if unaffected for the most part by this eruptive event on Sunday. Now, that's the only station where we see that trend, and we'll look at that here in a second. Finishing up the update from the Met Office, the magma tunnel that formed in the eruption that started on Sunday lies a little further east than the magma tunnel that went under Grindavik on November 10th. So interestingly, the data is showing that the dike that was formed on November 10th, remember we had the magma push through the rock, creating a lot of earthquakes. That was the earthquake swarm that really caused the evacuation of Grindavik. And that magma intruded and formed a 15-kilometer long southwest to northeast magma body, a dike, on November 10th. But the eruption we had on December 14th is a different conduit. So we have a different conduit that's a little further east, and the map will show that here in a second when I make that a little bit bigger. Based on the data collected and processed by Icelandic Institute of Natural Science and Land Surveying, it appears that they call it a sickle, but in English that's a graben, a downdropped block bounded by faults, that a new graben has formed to the east of the graben that formed on November 10th. It is about a little less than a kilometer wide, as can be seen on the map below. The maximum height is about 30 centimeters. but it's worth noting that the area is still sinking and the valley is widening. So this graben is still sinking in the center and extending or widening on its margins. For comparison, the trough, or the width of the November 10th one, was about 2 kilometers wide, and its subsidence or downdropping was 1.3 meters. With this new graben, cracks that had formed and were visible on the surface had previously been mapped. Those cracks have grown and new ones are forming. The risk of cracks and soil collapsing into them has therefore increased into the eastern part of Grindavik from what it was before. So unfortunately, in the town and just north of the town, all this movement of the crust of these surface rocks has formed a lot of fractures and cracks, both in town and just to the north of it. So let me switch you over now to the map, which I think is the most telling thing. And what we have here on this map is, let's see if we can, well, we don't want to zoom in more. Let's make it a little bit smaller. There we go. So now we have the whole margins of the map. So Grindavik is here. You can see the individual homes. And then let me walk you through this as best I can. The lava field that was formed on Sunday, January 14th, is shown in gray. So we have the large lava field to the north that was fed by this fissure system running in this direction. And then the small one is down here. I'll zoom in on it in a second. So this is the one that destroyed the 3 homes. So we've got the 2 gray patches. Those are the lava fields. We have the town and the homes. We have the main roadway, which is this black line running across the screen here that was taken out by the lava field. We have the roadway running to the east down here. And then what you can also see here is the berm. So the wall that was constructed prior to the eruption is shown right here. And you can see where part of the fissure erupted behind the wall. So that accounts for a lot of the lava we see south of it. A little spillover right about here. Another big spillover of lava across the berm right at the roadway. And then we can see the secondary berm that was built as well. The colors on the map, the blue and oranges, indicate elevation. So anything that has been uplifted is going to be into these oranges and deep red colors. So the berm is something that was created, man-made, and so that shows up nicely where they plowed all that earth material upwards. And then in the blues, these are areas that have downdropped or that have sunk upwards of 3 meters. So at the deepest blue levels there, or blue colors, that's a downdrop of about 3 meters, and then similarly a 3-meter rise in the elevation with the red. And so notably, you can see that and then one last thing here. So then we have the red line, the hatched line that is here and over here. That area constitutes the November 10th graben. So the downdropped area around November 10th that formed above that magma dike. And then over here with these orange lines with the little hatch pattern is the one that formed on January 14th to 15th. And this area has sunk or subsided. And what's interesting here is that you can see where's it at? Oh, here we go. The small fissure. So here's the fissure that opened up close to town, took out 3 of the homes. That vent, that fissure that we watched live on my live stream on Sunday, early Sunday morning for me, that coincides with this western boundary of this graben or this downdropped area. So everything in between these 2 orange lines has dropped in terms of elevation over the last couple days. So you can see that coincides pretty nicely there with that. And then you can also see that the bigger fissure and vent doesn't perfectly coincide with that, but largely parallels it and is quite close to it. So let me zoom back out and see if I can just do a little bit of a zoom there. Interesting. So it's got the whole situation become increasingly complicated, and I'm still trying to process everything and make sense of it. But this new map from the Met Office is very telling. All the other little black hatched lines that aren't colored are just cracks, ground cracks that they've seen open up in the topography. Some of these may be existing fractures that you could have seen, like they might be from older fractures from the ancient eruptions 800 years ago, but a lot of them, I believe, are new fractures or cracks. So interesting. We've got now two somewhat intersecting, not perfectly parallel structural grabens, down-dropped blocks with parallel and subparallel cracks that have formed over apparently two discrete dikes that also intersect. We can see them intersecting right there in the center. The grabens intersect, therefore it stands to reason that the dikes as well likely intersect. And so it's much more complicated than the silly sketch I drew that showed the sill coming over and forming one dike. It's really more complicated than that. And now we have two intersecting dikes. So this is a map worth spending some time with. It's on the Met Office page. I'll try to come back to the video description and add that in when we're done, but hopefully that helps a little bit. So interesting, very, very interesting. So let's turn now to some of the GPS data. And we could honestly spend an hour looking at all the stations and scratching our heads over this, but let me just give you a taste of it. I'll provide the link, and then some of you can deep dive into the weeds and look at all this geophysical data and see what you think. So let's start with the station that we've been monitoring the most, which is the one near the power plant, the Svartsengi station, and look at the GPS station there. So what we see here, and we'll just focus on the last little trend here. Well, we can go back a little bit. So through November, after the November 10th intrusion, we had uplift at this station, fairly steady uplift, a few gaps in the data due to stormy weather. And then that reached this point here on December 18th, when we had the eruption just to the east of the power plant. So then you could see a downward movement in the elevation, which is interpreted as deflation. So here we're inflating, the magma chamber is causing the land to rise over time. The magma is pressurizing more gases, the Earth's crust is deforming as much as it can, but then it reaches a breaking point and we get an eruption right here. So inflation, eruption, and then deflation. And then since December 18th, we see another fairly steady rise in the elevations. And then right here, there's that one single data point up there that coincides with the eruption we had on Sunday. And then since then, this is the part to really look at over here. Rather than seeing the deflation, this might be too zoomed in, sorry. That's pretty good there. Let me get that centered for you. There we go. So rather than seeing, we would expect to see right here, these red dots to the right of that dot that's elevated, we should see everything drop a little bit, a few tens of millimeters down, but it's not. It's actually staying right on that linear trend. That slope is more or less maintained. And if anything, you can see a little bit of an upward trend. Now, this is only a few days worth of data, but it's all we have to go on. It might be flattening out a little bit the last day or two, but there's an interesting trend right here. So this is something different. And this is part of what the Met Office update is talking about when they say that at Svartsengi near the power plant, there's no sign that the magma influx continues at the same pace. So apparently what might have happened is during the eruption on Sunday, the main body of magma under the power plant, we really didn't take away much from its volume. The magma that erupted on Sunday was magma that was in the supply chain between the power plant and the vents that opened up. So that small volume of lava that was erupted on Sunday, and it is comparatively small, was what was in the pathways, the plumbing system, the conduits between the main magma body here at the power plant and where it actually erupted. That's one possible interpretation, because you would expect if you're draining out some of the larger magma body here, we should see some deflation. We should see a drop in the GPS data, and we're not seeing that. And so, unfortunately for this area, the trend is right back to where we started, and it looks like we're going to be looking at another eruption possibly within days to weeks to maybe a month or so. So that's the Svartsengi station. Zoom back out a little bit. And the next one I want to show you, where things get a little bit confusing, is this station here, GRIV, which is just to the northwest of town. So this one here, similar trend, right? In November, here's the December 18th eruption right here. And then, so we get deflation and then more inflation. But look at this one, just like the Svartsengi station, this one has a pretty noticeable kick upwards. This one looks like it's a little bit, at least those first 4 points, elevated, a big jump up to this point, and then maybe stabilizing. Again, you can't put too much into just a 2 or 3 data point cluster, but until we get a few days or a week or so from now, this is what we have to go on. So don't want to come to any big conclusions, but it's a pretty interesting trend. It's even a little bit more remarkable than the Svartsengi one, and because it's further away, that indicates that maybe that magma body is bigger than we thought, or maybe there's more than one magma body. There's some ideas out there floating around that relate to that. I don't have any firm conclusions. I need to spend some time looking at this. So I'm happy to hear any ideas that might be out there. And then the final one I just want to show here, so we don't belabor this too long, is this station down here, pretty much in town, or at least on the eastern edge of town. And this one shows a real interesting trend. So this is not, we don't think, so this one I believe is not necessarily related to magma directly beneath the station. So there's a gradual increase. There's the December 18th eruption. Okay. This thing is much further away from the magma body, but then this big drop you see here, and let me zoom out so you can see the scale a bit. This big drop here is part of that graben forming, right? So it's in the area that was down dropped. It's in this region here shown in blue. And so there we're seeing a good maybe 300 millimeters or so of movement downward. So pretty incredible. Okay, so there's the GPS data. Let me grab my little reminder sheet here. Let's look at the earthquakes really quick. Earthquakes, not hugely instructive right now. Things are pretty slow. I know a couple folks before we got on the live chat today were checking out over here by Barabunga, this volcano here. There was a magnitude 4 that occurred in the last 24 hours, about 2:15 local time. And then there's a couple other ones in there. There's a 3.2, that's the 4, here's a 2.5, a couple smaller ones. These quakes are at a depth that I don't think it's ice. I think it's deeper, but it's only a couple data points. So I'm not concerned. It's an area that deserves a little bit of monitoring. A magnitude 4.0 is a good sized quake, so probably should have an eye on it, but I don't think there's anything here that suggests that something big's going to take place. So, and then back over here in the Reykjanes Peninsula, some small quakes. Everything's super small, like 1.2. I don't think there's any above 2 in the last 24 hours, and only a handful of ones above magnitude 1. We've just dumped a bunch of dense, heavy rock onto the landscape, and so you'd expect there to be some crustal flexure and stress changing around Hagafelt where the eruption occurred, and so these are pretty normal. None of these are indicative necessarily of magma migration in the subsurface. So that's it for some of the data. And then there was a another link that was sent to me from I'm not sure what this institute is in Iceland. It's the Institute of Earth Sciences in Iceland. So they have already analyzed samples of the January 14th lava. And so there's a nice little write-up here on what it was composed of in terms of mineral compositions, plagioclase, olivine, clinopyroxene. So if you're into mineralogy, there's some information there. This is what we call a thin section. So this is taking a sample of lava from the eruption, grinding that rock sample down to such a thin plane that light passes through it. And so and that allows us to use a special microscope to identify the composition of the minerals in the magma. So you can see this gray crystal here. That's a crystal of olivine. Olivine's a olive green colored mineral. If you see it in a larger piece, it's also when it's gem quality, it's called peridot. And then you can see these needle-like pieces of plagioclase, these darker, skinny, needle-like crystals in here. So both very common. These are probably the two most common minerals in basalt, which is what this is. This one's from the North Fissure, the bigger lava field, and this one's from the South Fissure, down by the houses, where some of the houses were destroyed. So some nice figures there. A plot of the composition. We won't get too deep in the weeds here, but this is just composition of magnesium oxide, and then this is potassium and titanium oxides. And what you can see on this plot is here's the South Fissure, so its composition. The orange is the North Fissure from this, again, January 14th event. The December eruption, December 18th, plots right there with the purple diamond. So notice how those two so closely align. All the little teal circles are various samples from the Fagradalsfjall eruption in 2021. And then the gray samples down here are looking at the older rocks, the ones that erupted between 800 to 1240 AD, analyzing those. And so you can see they're all pretty close in terms of their compositions. Excuse me, there's a few differences here and there. And then probably the most telling is their nice little summary here. The lava erupted at Grindavik is related to the magmas erupted at Fagradalsfjall and Sundukur, as shown by the ratios. It's derived from a more evolved, homogenized magma storage zone. So it's the same magma storage zone, but as it sits there in the subsurface and starts to crystallize a little bit, it gets a little bit more evolved in terms of its crystal composition. And the lavas are compositionally distinct from historic Reykjavik lavas, demonstrating that the Sundukur, so the December eruption, and the Grindavik, or the January 14th eruption, are a continuation of the magmatic unrest seen since 2021. So nice little article there, some fun data to share with you. So that's our geochemical analysis and some of the petrology. One little news story. So measurements show that Grindavik has calmed down. This talks about the similar thing the Met Office update did, but I'll put this news story in there too. It might be a little bit easier to digest. And then there's a little question answer with one of their geologists there, but it pretty much reiterates what we've already discussed. So I think that's all I have in terms of news. And so what we can do now is switch over to any questions you might have. And again, thank you to Susan for moderating those. I'm going to open my email over here. Okay, so she's got a first set of questions for me. Let me pull up something else for you guys to look at. She asked from Kate Bat, a few moderate earthquakes at Barabunga today, any significance or just the ice cap shifting? So I think I kind of addressed that one, Kate. I think they're deep enough that they're probably possibly related to magma movement underneath that area. Remember, that volcano sits right over the hotspot, but not enough to indicate that it's getting ready to erupt anytime soon. From Tess F. Hi, Shawn. If there's an eruption north of Grindavik, will the old cooler lava by the berm be helpful in directing the new lava away from town, or can the lava flow go over it? That's a really good question. And let's see, do I have a good graphic to put up to explain that? probably nothing I can pull up quickly. I want to get to that. Oh, let me get to this first. Well, let me answer the question, then I'll come to that. So this person's question is, if we have an eruption north of town, and let me go into my, I'm gonna need to get into Google Earth for this, which means I gotta switch something over. There's me, and let's go to this. Okay. Is it gonna switch on me? Well, I thought it was going to switch. I think we'll go back to that one. Well, now I can't get it to. Graham, if you can help me, I'm trying to screen share. I'm running through the Nature Eye live stream. Let's see. Oh, I just had to wait a minute. Yeah, when in doubt, take a deep breath. Okay, so yes, so the question, if there's an eruption, so we've got the berm I've drawn there in yellow, and that's the old berm. I haven't drawn the new one, but the new one's just more or less parallel to it and runs over here to the west. So if there's an eruption north of the berm, yeah, I think the lava basically, my first take is that the lava has added mass to the berm, and so it's less likely to ride up over that. That being said, there's more, a less steep of a gradient. The berm had this sort of steep embankment slope to it that made it harder for the lava to ride up and over. So I guess to answer the question more succinctly, I think it depends a little bit on which way the lava is being directed. If the lava is moving more or less due south, there's still a pretty good chance, given its momentum, even as it rides up onto that older lava, that it could go up over the top of it. But I think most of it would get directed out to the west. So I think the mass of lava from this December 14th eruption would help divert more of the lava away. That's my first quick take on that. So. Okay, so let me show you this real quick, and then I'll come back to a couple of the questions that was sent to me by Susan. And looking around, where is the window? There we go. Okay, so let me take you to this really quick. And so I had a viewer, John Adams from the UK. Let's see if it's going to pull it up. Why is it not working? But the screen share is a little. Come on. There we go. So John is an artist and drew this and said I could share this with everyone. I think this is fantastic. He kind of took the little two-dimensional sketch I had drawn and then changed it to a three-dimensional sketch, and more or less drew what we would see in 3 dimensions. And so this is fantastic. I wish I had this talent and ability, but he's got a deeper magma chamber, the sill under the power plant here. He's even got little cutaways, which is really kind of cool. And then here he has the dike that resulted in the eruption on January 14th. So maybe that's the southern fissure, and then the longer one up here. I think that he's done a great job of just showing a nice representation here of what this looks like. So I'm hopeful that this diagram helps many of you kind of visualize again kind of what we're talking about. I think my two-dimensional diagram helped to a point, but I think this really helps you see things in 3 dimensions. So he's got the road coming out through here, some of those taller hills like Hagafelt and Selingerfelt. He even has a fun little, what he's calling a transform fault, so a strike slip fault that has moved things laterally. So you can see a little bit of the offset of the sill and dike here, which is pretty cool. And then he's got this little thwarted dike. I call it an arrested dike, same thing, but basically dikes that propagate towards the surface, like we saw with November 10th, and don't actually breach the surface and form an eruption. So, so big, cool shout out to John and his amazing artwork there. So awesome. Thanks for sharing that. Let's go back to a couple questions. I might just leave that up for a minute. From Rocket Boy 3000. Hey, Shawn, tell us about polar magnetic reversals and how they're used to date the planet in tectonics. Oh boy, that is a 20 to 30 minute lecture. I might not take the time to do that now, because I'm sure if I get going, I'll just want to tell the whole thing. But basically, these lavas have minerals that have enough iron in them that they respond to the Earth's magnetic field at the time. And so as this lava flow that erupted Sunday, as that lava stopped moving, as it has the last few days, and started to cool and crystallize, those little tiny magnetic minerals in there actually align themselves with the Earth's magnetic field. They have an inclination to them. So if you're right at the Earth's magnetic poles, those magnetic minerals will be oriented vertically. If you're right at the Earth's equator or magnetic equator, they'll be horizontal. And if you're any place in between, they'll be inclined or tilted. And the degree of tilt indicates your latitude. So in Iceland, we would expect these little magnetic minerals, let me show it with a pen, that's better, to be oriented much more steeply, like this, than where I'm at in Idaho, where they would be a little less steeply. And where my friend Elaine is down in Tucson, they would be even less steeply inclined. And so you can use the inclination to figure out the latitude. So polar magnetic reversals aren't used as, oh, the reversals. Okay, so then, I guess I am making this a longer discussion, but I want to wrap it up just so I get time for the other questions. So then if the magnetic field results in a little crystal in the lava flow that's oriented this way, and now the magnetic pole switches, so we have a reversal of the magnetic pole. Now the south pole becomes the magnetic pole. Well, then these little minerals aligned this way would flip and point the other way, but they would still maintain the same inclination, if that makes sense, given wherever your latitude is, wherever you are north to south on the planet. And so we can, of course, date the rocks that have these minerals. So the age of the lava flow or the basalt layers can be determined using other isotopes. So it's two different things. The magnetic reversals can be dated. That's one technique. But the magnetic reversals are helpful in determining location, and that they were big evidence in the 60s that revealed to us that the continents had moved and that the Earth's crust and locations weren't fixed but were transient. So hopefully that's a pretty good explanation. So from Liz Schmidt, is this the beginning of a rift formation? Not sure that's the right term for it. The giant gully thing. It's probably too early to say, but it could be. So I think what she's kind of referring to there is, you know, as you get further into other parts of Iceland, like for example up near Thingvellir, there is, and this is the national park. This is one of the more popular destinations in Iceland. There's a similar feature, right? So over on this side, you have a big crack running across this valley. That's one side of the graben or the rift. And then there's another one on this side. And this is all part of the plate boundaries movement. So this area is sunken down or low in the middle. That's why there's a big lake there. And then you have this area over here on the sides that's elevated. But it's more than just one fracture or fault or crack. There's a series. In fact, you can see them all right here. You can see all these cracks running through the landscape, all pretty much parallel to each other. So yeah, so it's possible. It's you know, there's tectonic rifts and then there's volcanic rifts. Those are a little bit different. At this point in what we see in Iceland is we have a tectonic rift, I would call it, but it's driven partly by that intrusion of magma. So yeah, the names and semantics can get a little bit messier there. So okay, from Quiv1S, I'm wondering if we know what the upside down landscape of the underside of the Earth's crust looks like, the part where the solid crust meets the liquid magma, mountains like our side, or if I'm reading the question right, so where the crust meets the upper mantle, so the crust and the upper mantle behave somewhat similarly. There's a few differences, but they're solid and rigid. And then beneath that, you have the asthenosphere. So there's really no place where the crust meets the liquid mantle for the most part. You, of course, have magma in the subsurface, but it's not everywhere. It's being generated in little pods and pockets. What you really have is you have the solid upper part of the surface of the Earth, which is what the plates move on, which is the crust and the upper mantle. And then beneath that, you have a layer in the Earth called the asthenosphere that is easy. It's a weak layer. Think of it like the jelly in a jelly sandwich, and it deforms and it moves, and it's where magma can be generated, but it in and of itself is not magma. So hopefully that makes sense. So if you do the right things to this asthenosphere, like if you take the crust above it and thin it and stretch it, you can generate magma. Or if you take another plate filled with water in its pore spaces and drive it down into that layer, the asthenosphere, you can generate magma. So maybe that's a little bit helpful in kind of thinking about it. From Sheila Douglas, will this land ever be arable? So like farmable? Maybe. Like I'm assuming she's talking about like the lava flows in Iceland, and with this climate, it would take certainly centuries, hundreds of years, and maybe longer. Now, does arable mean you're farming it, or could you graze it? I think in Iceland, the moss grows pretty quickly within maybe a few decades. And then you get some of those pioneering plant communities that start to grow some grasses, and then maybe you could have the sheep out there on it. So, so will it ever be arable? Sure. Will it be arable in our lifetimes? Maybe not, right? These fresh lava flows, it takes some time. And it depends a lot on the climate. If you're in warmer, more tropical climates like in Hawaii, you can have those ferns and some of those pioneering mosses and lichen coming up pretty quickly, and you can even get it back to being fully vegetated within less than 100 years. There's even like lava flows in Hawaii that are from like 1801 eruption of Mauna Loa that are pretty much mostly rainforest on top of it. It's more or less completely re-vegetated. Mary T, what are the sand-colored areas to the east of the flow? So I think she's referring to the, oh, I got to get off the thing there. Sorry, I've got the wrong graphic up. So let's go to this one. So I think she's referring to this map here. So her question again is the sand colors areas to the east of the flow. That's areas that did not downdrop. So those are areas that are basically, their elevations haven't changed really since from December 1st to January 15th. The blue is the area that's sunk. From Frederick A, what about the quakes on Barabunga today? And we mentioned those. I addressed those. That was one of the first questions there. Great. So that was the first set of questions. We can go a little bit longer and see if there's any other questions. So if Susan could send me those, I'm going to try to peek into the live chat at the same time and see if there's any there. Yeah, we'll go a little bit longer. We've got, let's see, how many? many folks are on here? 4,200 people. That's great. Thank you all again for joining me and spending some time out of your day just looking at what's going on in Iceland and learning a little geology along the way. So Susan, if you could send me one more batch of questions, maybe just like, I don't know, maybe 4 or 5 or so. I can spend a little bit more time here with folks. And if I don't get your questions today, maybe you can put them together on the next one. Moving forward, we'll see how things go. This was, to reiterate, if you didn't catch at the beginning, the notification I got from NatureEye is that they've got to get some folks. They've had all these people on the ground in Iceland have been away from home, and so those folks need a break heading back home. And so while we have this lull in activity that we hope is happening, we won't have the ability to operate the drone over the next few weeks. I'm assuming that if something were to happen, they could mobilize quickly and we might be able to use it again. So today was probably our last drone flight with NatureEye for the next few weeks, unless something big happens. So I'll just look through. Oh, here we go. Second set. Thank you, Susan. So here's a couple more questions that came through. Okay, let's see, Susan. These are the same. The same questions were sent, so maybe you sent the wrong file. So maybe resend those if you can, real quick. Try that again. Yeah, if we can, I think Susan's going to resend me some of those questions. The file she sent was the same as the first one. And while I'm waiting for that, maybe I can just try to scroll through this chat and pull those up. And again, thanks to Susan. She's doing the yeoman's work here of aggregating all this. Super helpful. All right, let's see. Kelly Hills, are there other places in the world where people live on an active rift between plates versus subduction zone or hotspots? There's some places in Africa. So the East African Rift comes to mind, Kelly, as a place where there is an active rift with volcanoes and earthquakes that occur periodically in parts of Ethiopia and Kenya. There is parts of, there's the Salton Trough in Southern California that runs into the Gulf of Mexico, which is an active rift tectonically, where the plates are not only separating, but moving laterally. And we do have young volcanoes in that area, and we do have earthquakes. The Red Sea is another active rift. So maybe no one living in the Red Sea, but you have the countries on the margins of the Red Sea, Saudi Arabia, Egypt, whatever other countries might be over there. Those are a couple that come to mind. So there's that. And then here's the second set of questions. So thanks, Susan. Oh boy, there's a lot here. I don't know if I can get through all of these, but we'll try. Gail Vaught wants to know, it would appear volcanologists should have foreseen these fissures and rifts occurring and prevented building north. Now Grindavik may become totally inhabitable. Were people too complacent? That's a good question. Let me see. Let's switch out of that view real quick. It kind of what's kind of doing here is it's just showing one thing at a time, and when I switch, it doesn't show. So let's go back to Google Earth for this part, and let's see if that pops up for you guys. But yeah, this is something worth addressing. There we go. Okay, so back to Gail's question. It's messy. I mean, you can look at all of Iceland, all the land in Iceland, nearly every square meter of land is a result of an eruption at some point in the past, right? The Reykjanes Peninsula is part of the plate boundary. But remember that a lot of these areas were settled literally hundreds, if not maybe 1,000 or so years ago. So this area was settled. Oh, Amanda Jo mentioned that to me yesterday, like the year 900 or something. No one knew about tectonics and where volcanoes are or aren't back then. So did volcanologists foresee these fissures and rifts? No, all we can do is forecast things. So we can't say, we knew that since 2019, late 2019, that this region was becoming active again. It was producing earthquakes. There was indications magma was moving, but we didn't know exactly where any of it was going to erupt. And then, of course, we got the eruptions over here. I don't know why I'm missing the 20. Oh, there it is. So we had these 3 eruptions here in 2021 to 2023. But these weren't a big deal because these were, up in the hills, out of harm's way, and tourist attractions. I don't think anyone could have, once these started popping up, I think people knew that future eruptions in the region were possible. But it wasn't until really this last fall that it looked like things might be happening closer to the town. And at that point, the town's already there. So, yeah, I don't know how to answer that one because there's just so many angles to look at it from. I don't think people were too complacent. I don't think it's not a case of the volcanologists and the scientific community were shouting from the rooftops to the public officials and they were turning a blind eye. I think all things considered, I think that they did as well as they could have. Once they knew the power plant area was showing signs of uplift and magma was intruding, they started taking precautions and they started building the berm and they evacuated the town. At this point, the infrastructure is in place. You can't move the buildings. And so that's the part that may end up getting lost or compromised a bit going forward, because you can move people, you can move belongings, but you can't move the fishing port and the buildings. So let's see, from Brit, couldn't there be another sill that fed the last eruption while Svart saying is still rising? I suppose there could be more than one magma body in the subsurface. They could be stacked, they could be nested somehow, and it's likely it's more complicated than the simple little sandwich thing that I've been drawing. But until we have other subsurface data to tell us what the geometries and the extent of those magma bodies are, we're sort of assuming this most simplistic situation to try to make sense of it, but it's very likely. And Brits from the Netherlands, thank you. Steffi B, are there any plans you're aware of to increase the number of data collection devices in the area? Not that I know of. I mean, I'm just a geology professor in Idaho. I have no contacts really with any of the Icelandic scientists. If they want to reach out to me, that would be great. But I think they kind of just do their own thing. And so, yeah, I don't think, I would like to think that they're deploying all the data collecting devices that they can in order to get the most complete picture that they can. And they're technologically advanced and they have resources. So I'm assuming that they're doing everything they can there, but I don't have direct knowledge of that. Mary T, is the depth of a quake measured below sea level or below the top of the mountain? I think it's either measured from land surface or from sea level. So, and different organizations may use different reporting methods. So I don't 100% know the answer to that, Mary T. I think you're referring to that earthquake at Barabunga, and that it was so many kilometers down, but it's well below the ice and into the ground, into the rocks there. From Jins, was the harbor created by the same kind of geologic activity we're seeing now? It seems to be on track with the graben that's now subsiding. Yeah, so this peninsula here you can see is made out of older lava flows. So these were some of those flows that came down 800 years ago that formed this topography, and just fortuitously these lava flows made a small embayment along the coastline that became a nice little harbor to protect from the waves so the ships could come in and out. So yeah, so is it possible that the harbor is low and is inundated by the ocean because there's maybe some structures there that are controlling it. Possibly because it does somewhat coincide with that graben. So possibly. From Snarkmark, approximately how thick is the lava flow now that it stopped moving? It looks kind of even, but I can't tell if it's like 50 centimeters or 2 meters. So there was a Met Office map so if you go to the Met Office updates and scroll back a day or two, there was a map that actually, a really nice map they had that actually showed the thickness of the lava from this most recent eruption. And I think the most recent data at the thickest, it was around maybe 8 to 10 meters at its thickest, so about 25 to maybe 30 feet thick, maybe up against the berm, I think is where it was thickest. And then other places it's thinner, but you can look there to see that. Let's see, IRQ-60 they have ground penetrating radar. Do they have LiDAR? Do they have any other means of checking for the ground swelling? Yeah, I don't know what other geophysical methods they can use. We know that around November 10th, they did use some INSAR data. So that's satellite data, interferometry that allows them to see little changes in uplift. So it's a little, I wouldn't say it's better than GPS. It's different and it's a bit more comprehensive over a bigger area. GPS is one point, and the INSAR actually shows you a region of movement up or down. But you have to wait for the satellite to come by, and I think there's some limitations and such. But they do have access to that. Empty nest gardens. Without saying how you may have replied, I'm curious if any of the residents of Grindavik have reached out to you to ask, what would you do if you lived here? Will it get worse? The only Grindavik resident that I am in touch with is Amanda Joe, who's been helping me out with these updates since November. So no one else has talked to me, and no one's asked me for my advice on what I would do. And if that question was posed to me, I'd have to think about it because I think there's so many other factors, and I think it's a personal decision. I don't think that there's one answer that would work for everyone. I think some people might decide this is too much, I'm moving away. Some people might think, no, this is my home. I want to preserve this place as long as I can. And I don't think that you can say one answer is better than another. Peter Whatmore, with the land lowering, how much lower does it need to get before it becomes part of the sea? Mainly the town area that's sunk. Well, that's pretty simple to figure out because you can look at the elevations here. So, just over here, we're at like 19, 20 feet. I've got mine set to feet, but you can figure out meters. So that's maybe 6, 7 meters. I think you'd have to see substantial. I think there's some low areas out here on this peninsula as I'm looking at my Google Earth there. Some of it's only a meter or so, but there's no one inhabiting this area, and that's probably why they haven't built out here, is it's very low elevation and prone maybe to being inundated by big storm waves. Similarly over here, this is kind of a wetland area, but the main parts in town are at least 3 or more meters above sea level as I just kind of scan around the harbor there. Some of this industrial area looks a little low. So you'd have to see several meters of subsidence, the land sinking in this region in order for it to probably impact some of the infrastructure there. Ken C, what is the likelihood that lava will flow from the new cracks that opened in the middle of the town? It's possible. So everything's changing. Every little event, every inflation event, you might argue every day, the equation's changing. We've talked about that magma moves into the subsurface and takes advantage of whatever pathways that are there. And so whatever existing fractures become conduits that it can exploit. It can widen them with the pressure of the magma and the gases. So as you create more fractures in this region, you're creating more pathways that might be used. So the fact that there's these large fractures running through a Grindavik, they're very likely to be exploited by magma moving forward. Do we know that for sure? No, but they're of concern, absolutely. Amanda Joe just sent me a quick message that said, let's see, here it is. Yeah, and so sorry, Amanda, Joe, I missed some of these. Oh, the uninhabited area is the original town. So I'm assuming she means this is this peninsula here. We graze sheep there now, and there's walking and horse riding paths. You can still see ruins from the buildings there. So I don't know if she means the peninsula here or the area by the golf course, but one of those two was where the town was originally. And now they just kind of use it as a recreation and grazing area. Okay, a couple more questions, and then we'll wrap this up. Again, thank you all for joining me. Ken C. Oh, the one to the east of the harbor. Okay, so thank you, Amanda Joe. So this area here, this little peninsula, was where the original Grindavik settlement was. Yeah, if you could send me something, Amanda Joe, I'd be interested to know if we know when or why they moved the settlement off the peninsula and back around the harbor. Was it because just they started fishing, or did some of these buildings get destroyed by storms, possibly? But next question, what is the likelihood that the lava will flow? Oh, I answered that one, didn't I? Yeah, from the new cracks and into town. Paul Hendricks, what is the lightest gray color of each mineralogy sample from the north and south fissures? Well, why is the lightest gray color different shades of gray? I would expect them to be the same since the fissures were so close to each other. I'd have to go back and look at the photos there. It could be the actual thickness of the thin section. So a lighter shade of gray would be transmitting more light through it, and if it's more darker shade, maybe more opaque. Yeah, good question. And then the last question here from Biker Trash, is the hotspot getting activated? Magnitude 4+ quakes in the last week. Well, the hotspot's always active. It's just a matter of, is the hotspot, it's not so much what's happening with the hotspot at depth, it's what's happening in the shallower portions of the crust as the magma is supplied. So remember, the magma doesn't go straight from the deep source to the surface typically. Typically it comes up, reaches the level of neutral buoyancy, and then stays in the subsurface forming a shallow magma body. And then that shallow magma body is what feeds the eruptions there. So I don't think the hotspot has been active for a long time, but it's not continuously active like every day. The magma accumulates, the pressure builds, and then you get an eruption, kind of like what we're seeing here with Grindavik. And then, it's not cyclical, but you have these episodes punctuated over time where there's these eruptions. So great. Well, I'm like running out of steam a little bit here, and my mouth's really dry, and I've got some other things to get to. But this has been great. This has been super fun. Thanks to Susan Helmer for being our great moderator on the live chat. Appreciate her. Thanks to Amanda Joe for sending information to me and for just continuing to provide information. It's been tough for her to just deal with this drama and chaos every day. Again, it's a slowly evolving disaster, but for her it's a slowly evolving nightmare. And so just continue to provide her with whatever comments and support you can, and we'll hope for the best possible outcome. So I'll jump in again, and we'll do another update when the situation warrants it, maybe this weekend, maybe early next week. So it's still that time. Just kind of keep track of things. I'll add some of these links into the video description that you can look at if you guys want to look at some of the GPS data, if you want to scrutinize some of this information that we've looked at today. But thanks again for joining me. Appreciate your viewership. Appreciate all you do to support this channel and the geology education that I try to promote. It's truly appreciated. We've built a really fun community here. Thanks to the folks at NatureEye for allowing us to use the drone and have that technology and that view of the landscape. It's fabulous. It's far superior to me flitting around on Google Earth. So thanks again to everyone, and we'll get this live stream uploaded. And so if anyone misses it, they can catch it there. Thanks, be well, and have a great day.